Good morning and welcome back to NASA's Johnson Space Center for today's mission status briefing. This is Flight Day 9 of the STS-134 mission to the International Space Station. We'll talk about the activities on board the complex earlier today that went on, and also look ahead at the mission's third spacewalk coming up overnight. So to do that, we have the lead space station flight director, Derek Hausman, and the lead spacewalk officer, Allison Bollinger. So we'll start out with comments and then take questions. Derek?
Okay, thanks, Kylie, and good morning, everybody. Well, after a relatively quiet day yesterday, the Shuttle Endeavour crew plus their adopted crew member, Ron Guerin, got back to work today. As you may recall, we discussed yesterday, Ron Guerin has been on the shuttle schedule all along, so he woke up with the shuttle crew today. Now that the 25S crew is safely on the ground, the remaining two Russian crew members, who are, of course, Ron Guerin's expedition crewmates, are in for a long sleep. They were asleep all day while I was on console. They're going to sleep through the night, and then when they wake up tomorrow, they'll be back on the shuttle crew schedule. So starting tomorrow, we have a normal sleep shift, which will be a nice thing to have back. As I mentioned, the shuttle crew stayed busy on the space station today. As I'm sure most of you know, Greg Shamatov and Mike Fink are both veteran International Space Station long-duration crew members, so we leveraged on their experience on board the station and put them to work today. One of the critical station maintenance tasks that we got at least started today was repair work on the Node 3 carbon dioxide removal assembly. These carbon dioxide removal assemblies, or CEDRAs as we call them, have two desiccant beds that actually do the removal of the carbon dioxide. One of the two beds in this Node 3 CEDRA is beyond its useful life. So we brought up a new replacement bed or replacement cartridge on ULF-6 on this flight. And what the crew did today, Spanky, Taz, and Ron working together, taking turns, was to remove the actual carbon dioxide removal assembly unit from the rack where it resides in Node 3. They took it to the JPM area of the gym. They tied it down to a maintenance workstation, and then after EVA 3, 2 days from now, they're actually going to pull this desiccant bed out of the carbon dioxide removal assembly and then replace it with a new bed, and then we're going to bring that failed bed home. So that's important work to get us back to normal redundancy. Of course, we have a second CEDRA in the lab, so we're using that lab CEDRA in addition to the Vozduk unit in the Russian segment to do carbon dioxide removal assembly. But after this mission, we'll be back to fully redundant carbon dioxide scrubbing capability on the U.S. segment. The other piece of maintenance work that we did today was on the oxygen generation system. Again, some of you who have been involved in the past missions and keeping track of what's going on the station know that we're having some challenges with contamination in the oxygen generation system, and we flew what we call a remediation cartridge. It's basically a filter that is plumbed into the water line associated with the oxygen generation system. The crew today, again, our go-to station veterans, Spanky and Taz, in concert with Ron Guerin, worked on the oxygen generation system to install this cartridge and the associated plumbing. We're going to wait for the EVA 3 to be behind us, and then we're going to activate the oxygen generation system, have the crew check for leaks, and then start running the water loops through this remediation cartridge or filter in order to see what we can do about that contamination. In the briefing last night from Dana Weigel, she mentioned briefly that we had an electrical power system failure last night, and basically we have banks of switches, if you will, or circuit breakers called remote power controller modules, or RPCMs. One of the individual switches in that bank of switches tripped, and it removed power to a video switching device. And it's more than video. It's video and it's payload data. So once this switch opened, we were unable to downlink high-definition video to the ground. We were unable to downlink payload data. The payloads continue to operate on station, but the Payload Operations Integration Center in Marshall Space Flight Center in Huntsville was not able to get the data from the payloads while this device was not powered. So it was relatively important to us that we get it back quickly. In addition to that payload data, I should mention that it also affects our ability to uplink files to the station, uplink procedures and messages and such that the crew needs during the day, and also the IP phone, which is, of course, the way the crew uses the device that the crew uses to communicate with friends, family on the ground. So pretty significant impacts to day-to-day operations, although we don't consider those systems critical. They're certainly important in our day-to-day work. Overnight, the team put together the procedures needed to change out that RPCM or that circuit breaker device, and then at the beginning of the day today, we got that RPCM switched out. We powered on all the components, and now we're back to 100% in terms of the video downlink and also the payload data, the IP phone, file uplink, et cetera. So another good, relatively small in the grand scheme of things, but another good example of how the teams can react quickly to problems in real time. And of course, looking ahead, we have EVA 3 in front of us tomorrow. EVA 3 will be, in terms of the spacewalkers, will be a repeat of EVA 2 with Foystel and Fink going outside and Shamatov running the show from inside. And of course, we'll be using the new pre-breathe protocol for this EVA. We're not going to do camp out. We're going to use the in-suit light exercise protocol. And for the timeline and for the new protocol, I'll hand over to Allison to talk about the details.
All right, thank you, Derek. All right, I'll go ahead and get started with a brief summary of what EVA 3 will look like, since it's a little bit different from what we originally planned pre-flight. We'll start out the day, as Derek mentioned, with Drew and Spanky performing this EVA. It'll start out looking very similar, where our first major task is to install the power and data grapple fixture, or PDGF, on the Russian FGB segment. So the two crew members will translate with some tool bags out to the port side of the FGB. They will remove some multi-layer insulation and also caps that open up the receptacles where the power and data grapple fixture will be installed. Both crew members will then head back to the airlock, and they'll retrieve the PDGF and its associated frame and its cabling. Then they'll work together to inchworm that grapple fixture back to its install location on the FGB. Once it's in position, they'll soft dock it, and then they'll tighten the 3 feet that hold the PDGF onto the FGB. After they're complete with that, they'll install a VSC, or video signal conditioner, which is used in combination with the PDGF to allow the PDGF to be a future base for the SSRMS. Once they install that VSC, they'll route some cables to it, and that'll complete the work that we will perform on the PDGF for that day. We'll then start working on rewiring some of the power that's heading to the FGB. These are the Y jumpers, as we call them. We have a port and a starboard set. We'll first start out installing the port side of those jumpers. Spanky will make his way forward on node 1, and he'll demate 2 connectors on node 1 while Drew's standing by. Once those 2 connectors are demated, Drew will then demate a connection at the PMA FGB interface, and he'll hook up this new Y jumper and then give Spanky a go to hook up his ends of the Y jumper. Once we're complete with the port side Y jumper install, the ground will do some commanding to check out the new connections that we just made, as well as put the inhibits in place for the starboard side. On the original EVA 3, our plan at this time was to install the 1553 data cable that runs from node 3 to the PDGF. But since we weren't able to complete all the tasks on EVA 1, now during this time that the ground is performing the checkouts and putting the inhibits in place for the second Y jumper, Drew and Spanky will head back to the lab to finish up that lab EWC, or external wireless communications task, that we did not complete on EVA 1. The cable that we need to install is out there. The handrails with the antennas are already installed. The 2 crew members will just need to work together to release a micrometer of debris, or MMOD shield, that's covering the connectors that we need to get to on the lab. They'll open up that MMOD shield. Then we'll need to put an inhibit in place, which inhibits ISS UHF communications, upon which time we'll be relying on shuttle assets in order to talk to the EV crew. We'll demate 2 existing connectors that are part of the UHF system, as well as part of the existing external EWIS system. Once we demate those, we'll install the new EWC antenna, close up the MMOD shield, and then work on coiling the old EWIS cable and bringing that inside. Once we're complete with that task, and once the ground is complete with putting the inhibits in place for the starboard Y jumper install, the crew members will head back to the FGB node 1 PMA area. Then they'll work on performing the starboard side of those jumpers, with Spanky demating 2 connectors on node 1, giving Drew the go to make his connections at the PMA FGB interface, and then they'll work to get that new Y jumper cable installed. Once we're complete with the starboard side of the Y jumper, we'll work on cleaning up the work site. We'll ensure that we get all the tool bags back near the airlock. And then another change to the end of this EVA, we had nominally planned on heading out to ELC-3 on the port side of the truss to take still photos of STPH-3, which is an experiment on the newly installed ELC-3 carrier. But actually, we're going to change that up, and instead of using the EVA digital still camera, we'll actually be using the EVA IR camera, infrared camera, to take some infrared imagery of the Vader experiment, which is a part of the experiment on the overall STPH3 complement. Drew will be using this IR camera to get some imagery that the ground teams will use to help regain science on their experiment. And meanwhile, Spanky will be installing a multi-layer insulation cover on the grapple fixture on the high-pressure gas tank, which we also launched on that spare ELC3. So once those crew members are complete with the tasks on ELC3, we'll head back to the airlock and call it a day. And we'll still have with us at the airlock, in case we get a chance, we will have that 1553 data cable, which we weren't able to install. We'll have that outside with us. So if we have about 45 minutes left at the end of the EVA, we might get a chance to install that cable. If not, we could also take still photos of the STPH3 task, which we had deferred, as well as possibly stow some tools in the airlock toolbox. So with that, that summarizes EVA 3. I'll go ahead and talk a little bit more about ILE, or the in-suit light exercise pre-breathe protocol that we'll be trying out for the first time tomorrow. Just to give everyone a refresher on the camp-out pre-breathe protocol, which we've used about 70 times on the space station. So this protocol starts the night before the EVA, where the crew members don oxygen masks, and they're on those masks for about 60 minutes, at which time we depress the airlock down to 10.2 psi. Then the crew members remain at 10.2 psi for 8 hours and 40 minutes. They're isolated in the airlock by themselves overnight. They wake up in the morning, they don those oxygen masks again, this time for about 70 minutes. During that time, we repress the airlock back up to 14.7 psi. The crew members, while still on masks, are able to head out and maybe grab some food that they can eat later on, and also take care of personal hygiene items. Then they'll head back to the airlock. We depress back down to 10.2 psi. They doff the oxygen masks, then they work on donning their suits. Once their suits are donned at 10.2 psi and they're all buttoned up and pressurized, we start purging the suit as we repress back up to 14.7 psi. And then we spend 50 minutes in the suit doing a resting in-suit pre-breathe before we head out the door to do the EVA. For the in-suit light exercise pre-breathe protocol, however, we start the day of the EVA. The morning looks fairly similar to the camp-out protocol, with the exception that the crew members are able to wake up, have a normal post-sleep where they're not wearing oxygen masks. They can go ahead and grab breakfast and take care of personal hygiene items. When they're ready, per the timeline, they'll go ahead and don their oxygen masks. This time, they're on the mask for 60 minutes. During that time, similar to camp-out, we depress the airlock down to 10.2 psi. And this will be the 2 EV crew members as well as 3 additional IV crew members who will help with the suit donning. While they're at 10.2 psi, they'll don their suits with the assistance of those other crew members. Once complete with the donning, just like camp-out, we'll go ahead and, once the suits are buttoned up and pressurized, we'll start the EMU purge, and we'll repress back up to 14.7. That's at this point in time, once we're back up at 14.7, where we'll start 50 minutes of the light exercise. And so the light exercise is how we judge this. It's based on a rate of perceived exertion, or RPE scale, which ranges from 6 to 20. 6 is you're sitting there not doing anything, and we're asking crew members to target an RPE of 7. So this is equivalent to walking a mile in about 70 minutes. So it's a very light exercise. So with that, if we could go ahead and roll the video. This video that we're going to show is the crew members receiving the training at the Neutral Buoyancy Lab. You can see Spanky on the left and Drew on the right. During this 50 minutes of exercise, Mark will be running the show. They'll be exercising for 4 minutes, and then resting for a minute, and then exercising for another 4 minutes, and they'll repeat this process for 50 minutes. This is what we call the slow motion hokey pokey. So the crew members will be doing this for 50 minutes. Once they're complete with that exercise, they'll then do a 50-minute in-suit resting pre-breathe, similar to the camp-out. See Spanky threw in a little arm motions there at the end. So after the 50 minutes of exercise, we'll do 50 minutes of in-suit resting pre-breathe, and then we'll head out the door. We'll depress the airlock and head out the door. We're doing things slightly differently tomorrow, though, for EVA 3. Since this is the first use of this protocol, we're actually going to divide up the resting pre-breathe into 2 different portions. We'll start out, once the crew members don their suits at 10.2 psi and we repress back up to 14.7, they'll do just 20 minutes of a resting pre-breathe, and that will allow us to get some data, hopefully get some data on the ground to see how the oxygen tanks respond. And this is just nice to have data that the engineers are interested in getting. So we'll do 20 minutes of resting, followed by the 50 minutes of exercise, followed by the 30 minutes of resting pre-breathe before we head out the door. So that'll look slightly different than future EVAs. So just a few things to talk about the benefits of using this pre-breathe protocol. It's estimated that we're going to use less oxygen during this protocol. So post-shuttle retirement, this will be a big deal for station. The crew members also spend less time on the oxygen masks, which for some crew members can be uncomfortable. They're not isolated in the airlock overnight, which is also a benefit. The one drawback to this protocol, though, is that it does take longer in the morning to get out the door than it does with the camp out protocol. So the egress we estimate to be about 30 minutes later than if we had done camp out protocol in this EVA. So with that, that's my summary of ISLE, so we can go ahead and take questions.
Okay, we'll start here in the Johnson Space Center. Do you have a question? Go ahead.
Philip Sloss with NASASpaceflight.com for Derek. On the RPC trips yesterday, is this something that's common? And also, where is this RPCM in the station? Thanks.
Yeah, it's related to a generic problem that we know exists in the firmware that controls this bank of switches. And the way it manifests itself is kind of a spontaneous trip without any kind of associated current signature. It's essentially just a bit flip in the firmware that results in one of the switches opening. And the way we recognize is that we look at data and see no current spike. So there's no signature indication that would point to a real trip. Over time, we've been changing out these older style RPCMs with the known issue with the firmware, with updated RPCMs with this problem addressed. This particular RPCM, I believe, is in the lab. So it's obviously an IVA change out, and I'm pretty certain it was in the lab.
Okay, and Denise has a question.
Denise Chow at space.com. The changes that you made to the EVA 3 timeline, were those mainly get-ahead tasks, or were those going to be added to the fourth EVA?
The get-ahead tasks for EVA 3? Yeah, the tasks that we deferred from EVA 3, the installation of the 1553 data cable, that will possibly remain a get-ahead for EVA 4, but there currently are not any plans to change what's nominally planned for EVA 4 right now. So that timeline will remain the same.
Gina Sinceri, ABC News. I had a question. Someone in New York asked me to ask this for radio, which is just what makes a spacewalk so hard? We talk about 8 hours, and they say, well, they're out there floating around in these puffy marshmallow suits. Why is that so difficult? Would you mind giving us kind of a definition for our radio audience, please?
About why it's difficult? Oh, wow. Well, I guess, so while you are floating out there in space, you are in a pressurized suit. So as you're bending your fingers, I think the main fatigue issue that crew members talk about is their hands getting tired. Your legs aren't getting tired because you're not walking around. Your arms aren't getting too tired, but it's mainly your hands because you're pressurized to 4.3 psi. So you're actually, as you're bending your fingers, your natural suit glove wants to just kind of be outstretched. So as you're bending your fingers to grasp onto handrails or to hang onto your pistol grip tool or to perform other activities, you're having to fight against the pressurization of that suit. So I think that's kind of what causes crew members to get most tired after the EVAs is the constant hand fatigue of having to fight a pressurized suit.
Rob Perlman with CollectSpace.com. With regards to the 1553 cable, can you just explain what that does, and if you don't get to it, how important it is for the station?
Do you want to field that?
Sure. Okay. It's essentially the data connection between the power data grapple fixture and computers in the U.S. segment that allow the robotics officer and the MCC or the crew to grapple that PDGF on the FGB and then use it as a base for the arm. So without that 1553 data connection, we can't use that FGB grapple fixture as a full-blown base, i.e. from a PDGF on the US segment, grapple that FGB PDGF and then ungrapple on the US side and have a fully functional arm on that PDGF. So before we use that new grapple fixture as a base for the robotic arm, there will need to be a subsequent spacewalk to connect that 1553 data cable.
Any other questions here? Okay, we'll go to the phone bridge. Marcia Dunn.
Yes, hi, good morning. I'm wondering, Derek, do you have any update on when those pictures of the space station shuttle that landed in Kazakhstan. When might those be available to the world?
Yeah, I know the U.S. folks in Moscow and the folks who are at the landing site are working to get those images transmitted to the United States. I don't have an update today on what the expected availability is.
Great, thank you. And a question for Kylie: Are you guys going to? How are you going to alert people that those are available? Will you be sending out a news advisory, or do we just need to keep checking the website?
It's expected that they would be posted on the website at www.nasa.gov.
Thank you. And one last question, Derek. How much time passed yesterday with the lack of all the payload data, et cetera? With the breakdown that occurred, how many hours did all told before it was fixed?
See, the failure occurred like right at the beginning of my handover to Dina and the Orbit 3 team, and then the repair happened early on the next shift. So I would estimate on the order of 8 to 9 hours.
Thank you. That's all for me.
Okay, next is Todd Halverson.
Thanks. Todd Halverson of Florida Today. I was wondering if you might be able to tell us what the earliest time those photos from the high-flying photo opportunity might be available. Might they be available before the end of business today or in time for publication in tomorrow's newspaper?
I think it's a matter of days as they're recovered as part of the cargo that was in the Soyuz.
Okay, and so then, Kylie, you do not expect that they would be available today?
Not that we are aware of.
Thanks very much.
Okay, and Bill Hartwick then.
Yeah, thank you. A question for Allison. For those of us who timeline these things, does the antenna install simply fit in the block where the 1553 cable had been? And then I want to make sure the only other change is for the STP visible light photography you guys are going to do. You're just swapping in IR, but the timing of those events then would stay the same?
Right, and so the timeline does look slightly different. The 1553 data cable task was timelined for 45 minutes, and so the lab work that we inserted in there takes about an hour. So what we did was we just shifted all the tasks that come after that lab EWC work down a little bit, and this is what caused us to defer. In addition to the 1553 data cable, we also deferred on Spanky's timeline. I mentioned the restowing of the tools in the airlock toolbox. We deferred that task to a get ahead, so that allowed us to shift all the activities down. And we're also showing a slightly longer time. We had 30 minutes for the still photos of STPH3, and now we're showing 40 minutes for the activity at the end of the EVA.
Be thruster photos, does that stay or does that go?
We still have the PDGF and FGB thruster photos / cleanup shown for 15 minutes. I don't have at hand what it was before. We do have the photos as an opportunity as time permits. Since Drew will have the camera with him, actually taking those photos will only take a couple minutes. But the main purpose of that task was to help clean up the work site, put all the tools back inside the tool bags, and get them back to the airlock.
Thanks. And one question for Derek is, where do you guys stand today on discussions of whether or not to add a day to this mission?
Yeah, as I was walking into the briefing, Bill, my understanding is, and what was announced at the IMMT, is that the decision has been made by both programs not to add a day to the mission.
Okay, that must be all the questions on the phone bridge. Do we have any follow-ups here? Go ahead.
Philip Sloss with NASASpaceflight.com again for Derek. Could you give us just a transfer status? And I noticed in the execute package sort of juggling some of the tasks. I know they talked about, obviously because the Russian crew members are sleeping, not to do ATV unpack today. Are you still going to be able to get to all of that during the dock mission? Yeah,
the mid-deck transfer is going per the plan, so we expect to finish all that. I think we're probably an hour or two ahead on mid-deck stuff, and we expect to completely unpack the ATV, or at least come very close by the time Endeavour undocks. So transfer is going very well.
Any others? With that, we'll wrap up this briefing with a few programming notes. The shuttle crew and Ron Garin again are wrapping up their morning on board the station. At 11 a.m. then we'll have a video file from the Soyuz landing events that will air on NASA TV. Then the Flight Day 9 highlights will begin airing at 12 p.m. Central Time. And we have an update from the International Space Station Flight Director on console in Mission Control at 4:45 p.m. And that crew then is scheduled to awaken at 6:56 p.m. and begin the preparations with that aisle activity to get ready for the third spacewalk, which is set to begin at 12:46 a.m. And with that, we'll send it back to Mission Control. Thank you.